Hello, and welcome to our lesson on frequency tables and time series graphs. Today, we will explore how these concepts build upon our previous understanding of two-way tables. By the end of this lesson, you'll have a better grasp of how to organize and represent data using these new techniques. In this lesson, we'll focus on understanding how frequency tables and time series graphs relate to two-way tables. Here's a brief roadmap of what we'll cover. We'll start by recapping how to create and interpret frequency tables, which help us organize data in a meaningful way. Next, we'll dive into time series graphs, which allow us to visualize data trends over time. After this, we'll run through some practical examples to apply our newfound knowledge, solidifying our understanding of these concepts. To give you a quick refresher on what we've covered so far, you've become familiar with key data terminology such as population, sample, discrete and continuous data, and primary and secondary data. Additionally, you've learned about grouping and organizing data, which sets the groundwork for today's lesson. With this foundation, we can introduce new mathematical techniques like frequency tables and time series graphs. These tools are essential for summarizing and visualizing data. For instance, imagine you conducted a survey on daily temperatures over a month. A frequency table would allow you to categorize and count occurrences of specific temperature ranges, while a time series graph would help you visualize temperature changes day by day. These representations make it easier to identify patterns and trends that might not be immediately obvious from raw data alone. Recall our previous lesson on recording data, where we looked at frequency tables and two-way tables. As a quick refresher, let's construct a frequency table for data on daily temperatures. We start by identifying the categories or intervals for the data. In our case, the categories could be ranges of temperatures, such as 0 to 10 degrees Celsius, 11 to 20 degrees Celsius, etc. Write these down in the first column of your table. You would now go through your data and tally up how many times each category occurs, then count the tally marks and write the frequency in the second column. Here's an example for temperatures over a month, a 30-day period. This table simply shows how often each temperature range occurs, providing a clear summary of your data. We'll now introduce time series graphs. While frequency tables are excellent for summarizing data into categories, time series graphs offer a powerful way to visualize data over time and spot trends. Here's how to create a time series graph. You start by collecting your data at regular time intervals. This could be daily, monthly, yearly, etc. For example, you might be recording the number of visitors to an amusement park each month for several years. On a graph, label the x-axis with your time intervals, for example, days of the week, months, or years, and the y-axis with the variable you are measuring, for example, number of visitors. Now plot the data points on the graph. Each point represents the data value at a specific time interval. Finally, connect the data points with straight lines to show how the data changes over time. Here's an example of what a time series graph might look like for monthly visitor numbers. By examining the time series graph, you can easily identify trends such as an increase or decrease in visitors over time. For instance, you might notice that visitors increased steadily until 2020 when there was a sudden drop. This drop could suggest something significant happened in 2020 that affected visitor numbers. Connecting back to two-way tables, both frequency tables and time series graphs take a more focused approach on either categorizing data or showing data over time. While two-way tables provide a snapshot of frequencies across two variables, frequency tables simplify this to one variable, and time series graphs extend this to show changes over a time period. Understanding how to use these tools will enable you to organize complex datasets more effectively and recognize patterns that could help in making informed decisions. Now let's move on to some practical examples to see these techniques in action. Imagine you've surveyed a group of students about how many books they read in a month. Here are the responses presented in a frequency table. By using this table, can you work out how many students were surveyed in total? We can achieve this by summing up the frequencies, which gives a total of 24 students surveyed. Next, let's consider daily temperatures recorded over a week, as presented in the following table. Try using this information to plot a time series graph to visualize the temperature changes over the week. We start by drawing the x-axis representing days of the week and the y-axis representing temperatures in degrees Celsius. Make sure the range of your y-axis reaches the highest temperature recorded. In this example, it makes sense to go up to 25 degrees Celsius on our y-axis. We can now plot each data point on the graph, then connect the points with a line to show the trend. You can now easily observe how the temperature fluctuates throughout the week. Let's do one final example. Suppose you have data on the number of cars passing through a junction each hour from 6 a.m. to 12 p.m. on a particular day, as given in this frequency table. How can we visualize this data to identify trends? One way would be to use a time series graph. Our x-axis would be the hours from 6 a.m. to 12 p.m., and our y-axis would be the number of cars. Plotting the data points and connecting them gives us this time series graph. By doing this, you'll see the peak traffic times and how the number of cars changes throughout the morning. These examples show how to tackle GCSE-level questions using frequency tables and time series graphs. Practice creating and interpreting these representations to strengthen your understanding and ability to analyze data effectively. Before we finish our lesson, let's consider the historical background of time series graphs. Time series graphs have been used for centuries to track astronomical events and weather patterns. Early astronomers like Tycho Brahe meticulously recorded data on celestial movements to understand the stars and planets better. By plotting this data over time, they could identify patterns and make accurate predictions. These early time series graphs laid the foundation for our modern understanding of both astronomy and meteorology. In today's lesson, we explored the use of frequency tables and time series graphs to organize and represent data, building on our previous understanding of two-way tables. We began by recapping how to create and interpret frequency tables, which focus on categorizing data into intervals and counting the occurrences within each category. This method offers a clear summary of data, making it easy to identify patterns within a single parameter. Next, we delved into time series graphs, which visualize data trends over time. We discussed the steps for creating these graphs, including labeling the axes with time intervals and the variable being measured, plotting data points, and connecting them with lines to show changes over time. These graphs are particularly useful for spotting trends and changes in data, such as an increase or decrease in visitor numbers to an amusement park over several months or years. We also touched on how these techniques relate to two-way tables. While two-way tables provide a snapshot of frequencies across two variables, frequency tables focus on one variable, and time series graphs extend the data visualization to show trends over time. By understanding and applying these tools, you can organize complex datasets more effectively and recognize important patterns, aiding in making informed decisions.